So now the question gonna be, what is the total force that apply on marble A? Let's put here, what is F, A, question mark. That's what we want to find. And I'm just gonna remind you that what we had here, we have marble B that applies some repulsion on A, which is this red. And we have another one, let's put it in blue, which is some attraction from marble C. So what is the total force that apply? And for solving that, we're going to use some really important friend, which is the superposition. What is the superposition? So the superposition is something that's gonna really help us in many situations. So instead of solving a really hard equation, we're gonna solve two simple ones and just sum them up. And you're pretty useful used to the concept of superposition without thinking it. You can think about the mass. So if I lift something up and somebody put something else on top of what I already lifting, so I'm gonna feel the force of the first one and the second one, right? So we're gonna sum them up. This is the force that apply on me. If I play with some kids and somebody pull my hair to this direction, another one pull it back in this direction, so I'm not gonna feel this force and this force only. I'm gonna feel the superposition of them, some diagonal force, right? Both this one and this one. And this is exactly what happened in this equation. So we have the superposition, and what actually the superposition says, it said that sum up all the forces, no matter who is it that do it, that apply on A. So we know that we have two of them, right? We have the red one, you see, which is B. If you remember what was the force V, B was K, Q, let's put it in here. So B was K, Q square over 5. This was the magnitude. And what was the direction? Direction was 0.6, 0.8. And we have the blue force, which is the force that apply from C. What was that? That was K, Q square. And we had here a 0.8 and 0.6. And now all what we need to do is to sum them up. And if we sum them, we're gonna get this form. I can take KQ square outside, KQ square, and I'm gonna have this term here, which is 0.92. You can calculate it, 0.44. I just sum the x's and the y values, and I didn't forget also to divide by 5 this term and this term. Perfect. And I can also normalize it, right? This is almost normal, but let's normalize it. It's K Q square over the magnitude of this vector, which is 1.02. And this value, which is, sorry, I divided by this and multiplied by this, sorry. So this is 1.02, almost normalized, you see it's almost 1, K Q square, and here I have the direction of the vector, which is 0.9. You see it's almost only at the x direction, right? Almost only the x direction, but a little bit to the y. And the both positive, okay? Why I insist talking about that? Because I want you to see that this one, this value, is really similar. Sorry, why did it red? I meant to do it in blue. So this value is actually pretty similar to this one, you see? So what I want you to see here, that C have, so the vector is actually a little bit tilted. Let's do it with green. The actually vector is now a little bit tilted. So what's happening? A and C attract so strongly because C have such an enormous charge, minus 20 Q. It's so strong that he hold most of the effect, most of the force on A, the marble A. But B is also in the picture, and it's tilted a little bit, a small repulsion to the side, and this is the reason you have this small shift. But it's important to see that what I got is exactly what I expected to have. Expected to have that C gonna affect more than A. So in this kind of question, you can always use your intuition to solve it. Let's go to the next section, which is the last part of this question.